each test run. The database cleanup and server reboot are for the purpose of keeping a consistent environment for each run of your test execution. Some people may think that it's not necessary, but my suggestion is that it should be done. Same for some web or application server cache. If the first test you did have no cache and a clean database, and after you finish the first test, if you don't delete the cache and you don't refresh your database for a second one, then the second one may perform better, really. So it's always good to refresh everything back to a consistent state for each test run. This is a response time graph, but not from LoadRunner. I will show you a LoadRunner one later. We will have to capture, because LoadRunner, when you do a 40 user test, it will give you the 40 users test response time graph. If you want to compare all different loads, then you have to capture all the raw data from LoadRunner, generate that graph from Excel. Not difficult at all. Just copy and paste into Excel and then generate the graph. So look at what we have in the bottom. They are all the transactions that we saw before in the previous slide. And now you may understand why we have the sequential numbers for different transactions. If I just want to look at managers managing direct reports, I just want to see how that performs. Without the numbers, you have to look at all the tags, all the lines to find that one. But if you have numbers associated with the transaction name, then you can look up the number. You know that it's 38 somewhere, and then you know that it's that one. And we mark a red line for 5 seconds. That is because during discussions with different business groups and server groups, we come up with a 5 seconds acceptance criteria for the performance. And we mark that line, and then we can see that, let's say for 40 users, which is the red line, the blue line, most of the transactions are below that, but a couple of ones are above 5. So you can see which ones are not meeting the performance criteria, and then you can do further troubleshooting for that, or just live with it.
Why are they? Is this a case where every scenario was given the same 5 seconds though? Like, wouldn't they have said that for a more data-intensive process it should be 7? We're willing to take 7 because we know what's going on, and maybe because managers are doing it, it's okay, we can waste their time, but don't waste everybody else's time.
Well, exactly why I said that we have to live with some of these, because we know that, for example, this guy, some managers may have only 10 direct reports. Some managers may have 62 or 80 direct reports. Right. Loading the page with a lot more direct reports obviously will take longer. So after we establish a general acceptance criteria for general usage of the system, then we identify the known intensive transactions for different users, different people. And then we know those will always be higher than 5 seconds. And ideally, we should also mark another line for, okay, we know that certain intensive transactions should not get more than 10 seconds. So we should even.
Because you would be talking to those people at the design phase, and you would theoretically come up with that as an option. You want to manage their expectation. But otherwise, they look at this and they say, well, how come this one's like through the roof? And then you finally figure out that it's because Joe has 67 reports and everybody else has 10 or something.
And you may have noticed all of these different transactions, they are really just the test scenario names. But this guy, direct report load time absence manager, that should be one scenario, but we split it up into different number of direct reports because we already foresee that coming.
Yeah, okay. Yeah. So that's why it's climbing like that, because you're increasing the data on the screen or the lookup that's happening.
Any other questions about this nice graph? Okay. The previous graph will allow us to come up with this kind of analysis. Because we at the end of any performance or load testing exercise, we have to come up with some statements to present to maybe different group business users. They don't like to look at graphs, they don't like to look at figures, they want statements. So creating the graphs and looking at the data ourselves will allow us to come up with certain statements. Some of these are projections. Not really guessing, but projection. We can see that I may not have it here. Yep, I don't have it on this slide, but when I say projection, let's assume that we have a 120 user test, and most of the transactions perform below 10 seconds. But we are not going to run a 240 user test. So, and we know that the system does not break at 200 users. So you can kind of make a safe projection saying that, okay, it should work with 240 users because it worked for 200, but the response time may not be just double 120 because things don't work that way. It may be longer, it may be higher than the averages from 120 users. But those kind of projections we can always make to make people happy.
Why wouldn't you just run it? Like, why don't you run like a worst case scenario? Like, is it a lot of work to do that, or?
We will run that. For this particular project, the different level of loads you saw, 40, 80, 120, 160, 200, we do a realistic ramp-up time, meaning one user every 2 seconds. We also do unrealistic stress ramp-up time, 10 users every second. And the system completely become unresponsive and hang, and we have to reboot the server where we do the 120 users stressed. So at 120 users, 10 users every second, the system breaks at 5 minutes, right after when all the users all the users are in. They may not even be in because the system may break at 80 users. So that will be kind of the worst case scenario, because worst case scenario is more like a trial and error. We do the stress test also by increments. We start with 40 users, 10 users every second. That means 4 seconds, you have 40 users in. The users still stable, you still get response time, so okay, that works. Try 80, the lock-in process become longer, but once the users are in, things are back to normal. So okay, 80 works. So we go to 120. 120, when you have around 100 users in the system, everything's stopped. And say the server management group cannot even remote desktop to the server. That means the server is completely hacked. Then we know that at around 100 users, with that kind of